Hello everyone, welcome to AWS Tutorials. In AWS Tutorials, you'll learn about AWS services. Recently, I've been working on some videos which is based on my viewers' feedback. They want to discuss design of certain use cases, and that's what I'm covering in nowadays videos. So today, my topic is how you can use a single AWS Glue job to do multiple transformations. So let's get started. Actually, this tutorial is in the continuation of a scenario we discussed in one of my earlier videos. So we discussed a scenario where we are talking about ingesting data from a JDBC data source, and we have multiple tables in that database, and we want to create a single pipeline using a single job to ingest data to multiple S3 bucket. So there are multiple source tables, there are multiple destination locations, but the ingestion is happening through a single pipeline and a single job inside that. So that's the scenario I have discussed earlier. If you have, and this scenario you need to know in order to go through the rest of the tutorial today. So I am providing link of this video in the description box, and please go through this video first before you continue to the rest of today's tutorial. So as I mentioned that I talked about developing a single pipeline using a single job, but then parameterize the job so that the single pipeline can ingest data from multiple tables to multiple S3 bucket. When you are building such pipeline, there are certain requirements. These pipelines, this single pipeline based design is built in order to meet certain requirements. And the requirements are that these tables have single ingestion schedule, which means that all the tables has to be ingested at the same time. Suppose you have 50 tables and you want to create a single pipeline, and all those 50 tables has to be ingested at the same time. Whether you're doing it daily or weekly or monthly, frequency could be different, but these tables are ingested at the same time. With a single pipeline, you can also create dependency between ingestion. Suppose you want to ingest your master table first, then your child table. You can create such dependency if you want. You can also do parallel ingestion, which is a very common requirement where you want to say I have 50 tables and I want to ingest 10 tables at the same time, then next 10 tables, then next 10 tables. You can do that kind of parallel ingestion as well. And in such case, we used a single job. And generally, like if you're people using a single pipeline, generally people use a single job to handle the transformation, and that single job and generally transformation is considered to be standard across each of the tables. So for instance, you will simply read the data from the table, convert that data into say Parquet format, remove some empty rows and those kind of things, and then you simply write that to the S3 bucket. So generally people try to handle standard transformation. But this is the last point where I want to focus today. There are methods where even if you're using a single job and you want to handle multiple transformation, you can do that. What I mean by that is that so I know that in the previous tutorial I talked about generally people going for single pipeline will have a single standard, like will have a standard transformation across different ingestion. But there are methods available. There is method available where you can actually handle multiple transformations across individual transformations for each of the individual ingestion. You can handle that, and that's a solution. That's a scenario I want to focus today. So again, we are talking about a pipeline where we use a single job with a common code, but that job is handling multiple transformation. So just to make it visually very clear, so we have got suppose 4 tables: customers, customer profile, orders, and sensor data. And then I'm creating one ETL pipeline. And this pipeline is using a single job with a common code, same code, no change in code. But still when this job runs for customers, it does a different transformation. When it runs for customer profile, it does a different transformation, and so for orders and sensor data. That means I can meet a requirement where I have a single pipeline, I have a single job, but each of the jobs are actually doing a different transformation depending on the table specific requirements. So how do I achieve this kind of design? Because this is very powerful, because then I can use my single pipeline for standard transformation based jobs as well, or even multiple transformation based job as well. So how do I handle this multiple transformation based jobs? So how is that possible? The first thing, you have a job which has just one code. This is very important. Since it is a single job being reused for multiple tables, we don't want, so the code is same. There is no change in the code. So it's a one code, single job. But then since we want to handle multiple transformation for each table, you want to segregate the code of transformation. So for instance, this job has got like one standard code, but then there's a separate code for orders, there's separate code for customers, separate code for customer profile, and so is for sensor data. But then what we need to do, that when we call this job, somehow automatically I need to associate this transformation with my job, so that when this job runs for orders, it takes care of order transformation using this part of the code. When job is doing transformation for customers, or doing ingestion for customers, then it's taking care of customers table transformation based on this code, and so for the other tables. So how do I do this dynamic association of this transformation code with the single job, so that job can take care of table specific transformation requirement? And that is possible using a special job parameter which can be used to dynamically associate code with your glue job. So the way it works is that you create your transformation code for your tables like orders, customer profile, or sensor data, and you save this code into a S3 bucket. Well, you don't save the Python file itself, but you basically create a transformation code, then you zip it, and then you upload it to the S3 bucket. And then to this single job, you dynamically assign these individual transformations code using a glue job special parameter called --extra py files. Using this glue job special parameter, you can dynamically associate a particular transformation code with a glue job, so that your glue job can handle multiple transformation. So the way it will work is that when this glue job is run, and when it is running for orders table, dynamically this order table transformation will be associated using this special parameter. So the glue job will run transformation based on this code. And similarly, if it is ingesting data for say customers, it will dynamically, this customer's transformation will be associated with the glue job, and that way glue job can simply run transformation for the customer table, and so for the other two tables. So you can use glue job special parameters to dynamically attach this transformation code to the glue job, and a single code, a uniform code, can take care of multiple transformations across individual tables. So how does this code look like? Because that's going to be the interesting part. How does the code is going to look like? So first of all the transformations are stored into S3 bucket. So there are a few requirements, of course, you have to meet. And I'm saying this is one pattern. I mean, there could be other patterns, but I'm talking about one of the simplest pattern you can think of. So first of all, each of these transformations are stored into a different location into S3 bucket. Okay. Then each of the transformation will have same file name. So this is a transformation for orders, but this is also called my transformation.py. For customer profile, my transformation.py. For sensor data, my transformation.py, and so is for the other table, my transformation.py. So each of these transformations code should have the same file name. That is the first requirement. Their location could be different. They could be in different folders, different buckets. That is fine. And in fact, they have to be in different folders and buckets. But their file name should be the same. Their file name and their zip file name both should be the same. Then they should have the same function name. So like in this case, my function name is transform. So I call a transform function, I create a transform function where I pass data frame as an input. And in this transform function, you can perform any kind of transformation you want to create on this data frame. And right now in this example, you can see I'm simply selecting some field. But you can do chaining of your transformation. So you can say, okay, let me select fields, then let me apply some filter, let me do something else, and then something else. And finally, whatever data frame comes out, I return it back. So in this transform method, you can chain your different transformation one by one, back to back, to do your table specific transformation. In this example, I'm taking a simple example where I'm simply doing one transformation, which is selecting a different set of fields depending on which data I'm dealing with. Like from orders, I'm selecting order number and amount only. For customer profile, I'm getting service ID, service used, and age, and so on. So three different requirements for your transformation code. First, they have to be stored in a different S3 bucket. Second, their file name should be the same. Third, their function name should be the same. And then within that function, you pass a data frame as the input. Then on this data frame, you can run series of transformation to create an output data frame. And that output data frame you simply return back. Yeah, it's as simple as that. Now, my transformation code look like this. So how does my glue job code look? So my glue job code looks something like this. First of all, you import my transformation. And now it will start making sense to you. Since I have kept my transformation file name the same, I don't need to change my code. I can simply say import my transformation, which is true for any of this code, right? Because each of the file names are my transform.py. Then here in this example, I am reading my data from a catalog, and then I am doing my transformation. I'm simply calling the my transformation.transform method, passing my source data frame, and then. So you see, again, here my code remains the same, common code, because this transform method is available in all these files. So all this code. So same code for me. I pass my source data frame. I get my destination or result data frame out, which I simply write at the destination in this example. So you can see here, my job codes remains the same because my file name, which I need to import for my transformation, is the same, and my method called is the same. Now all I need to do using that glue special parameter, that dynamically I assign these files to the glue job whenever I am doing ingestion for orders or customer profile or census table, so that when, for instance, I am ingesting orders table, I dynamically associate this transformation. And that way, when this method is called, this code will run. Similarly, if I'm ingesting customer profile table, I'll dynamically associate this transformation to the glue job, and that way, this transformation will run. And without changing my glue job code. So that's how it works. I'm going to show it in a demo, so you will see this in action. It will probably make more sense. So what we are going to do in the demo is that I'm going to, the pipeline I used for the previous tutorials, same pipeline I'm going to use. So I have a Redshift database where I've got 4 tables. I'm creating a single pipeline using a single job, which is going to ingest this data, these 4 table data in parallel to 4 different S3 bucket location. But I have got 4 different transformation code which I'm going to dynamically associate for each of these job instances, so that each of these tables get their specific transformation done. Okay, so let's see this demo in action. So here I am in AWS console. I have got my Redshift cluster in place where I have got those 4 tables: orders, customers, customer profile, and sensor data is there. Now I have created actually in my S3 bucket, I have created basically 4 folders: customer profile, customers, orders, and sensor data. These are my destination location. That is where I want my job to write the output. Then I have also got a transformation folder where I'm keeping all my transformation code in different buckets. I'm going to show you at later point of time. But let's look at this destination folder locations first. So you can see here I have got my Dojo data customer profile, where my customer profile data will come, which is empty at this point of time. This is my demo data lake customers folder, where I have got my, this is again empty, and my customer data will come. Here my order data will come, and here my sensor data will come. Right now all these buckets are empty. Then in glue job, I have created some databases. So I have created this Dojo database, and if I look at the tables of Dojo database, actually this Dojo database has got 6 tables over here, but and those tables I have simply cataloged using crawler. So these are, you can see, these are the Redshift tables which I have simply cataloged, and I'm interested only in this customer profile, sensors, and orders table. Now this is how my glue job look like. So if I go to my glue studio, I can see my JDBC data ingestion. And if I look at my code, this is how my code is going to look like. I showed you this code earlier as well. So it's a typical glue job code where I'm doing, so first additional thing is that I'm importing my transformation for library here. Then I'm trying to read some job parameters. So I have created parameters for catalog database, catalog table, and destination location. So these parameters I'm going to pass to my glue job dynamically, because I'm going to use a single job for all the tables. So my table name, my database name, my table name, my destination name, that will change with each glue job, and that's why those things are parameterized. So I'm simply reading my parameter values here. Then I am using this table name and database name. I'm simply reading the records from my Redshift database. And then I'm simply calling this transform method, where I'm passing this dynamic frame over here. And when I'm passing this dynamic frame, this transform code will take care of converting this into some kind of a resultant code or destination data frame. And then this destination data frame, I'm simply writing it to the S3 location. And in the S3 location, my destination is again parameterized. That means for each table, I can change my destination location, and simply I'm committing the job. So that's how my job code look like. Since I'm going to do data ingestion in parallel, I have also enabled concurrency to 4 or higher, because I'm going to ingest 4 tables in parallel. That means my job is going to run 4 instances in parallel, and in order to accommodate that, I have set up my concurrency. I can set up to 4 as well, but 4 and higher will be okay, and I set up 6 here. Then I go to my transformation. So this is where I am keeping my, so under my my demo data lake transformation folder, I have created 4 subfolders, and each of these folders are keeping actually transformation code. So if I look at the code here, this is how my transformation code look like. So if you look at, this is the code for sensor data, where I'm simply writing a transform function, which is taking data frame as an input, doing some filtering on the columns, and then I'm simply returning the data frame. But as I mentioned earlier, this code you can change, and you can put a chain of transformation here to do more complex transformation as well. Similarly, this is my orders transformation, where I'm picking different set of columns. This is my customers transform, picking different set of columns, and this is my customer profile transformation, which is picking different set of columns. Now each of these actually codes, each of these files have been compressed using compressed as zip, and then those zip files are then stored in S3 bucket location. So if we go to customer profile, you can see my transform.zip, which is the same Python file which has been compressed. If I go to customers, I can see my transform.zip, and so on and so forth for the other 2 tables. So for each of these 4 tables, I have got 4 my transform.zip file, which is nothing but the compressed Python file. Now, the last one, which is my step function. So here I have created the step function workflow, which is simply going to a single pipeline, which is going to basically run the ingestion for 4 tables. So if I edit this pipeline, you can see here this. Let me go to Workflow Studio, and let me remove this part here, and let me minimize this part here. So you can see here I have added 2 parallels over here, because I want to show you that you can do parallel data ingestion. In this case, I'm using the same glue job 4 times, running 4 times in parallel to ingest the data. So same one glue job I'm running 4 times. But when I look at this glue job, actually, if I click on this one, it is the same glue job, but here my parameters are different. So my parameters, you can see my job name is the same, JDBC data ingestion. That was the job I showed earlier. But then here my parameters are changing. So for instance, you can see here my arguments are, this is my catalog database, source table name, source database name, source table name. This is my destination location. And this is the 4th thing, which is, this is my transformation code. So if you look at this one, this is orders. So it is going to transformation, orders, and then my transformation.zip file. And that way, dynamically, I'm passing it my transformation code to the glue job, so that glue job, when it runs for orders, simply uses a transformation stored over here. Similarly, if I go to customer table, you can see here my parameters, my job name is the same again, my database name is the same, but table changes. Now table is customers, my destination is customers folder, and then my extra Python files, the transformation code is now transformation, customers, and my transformation.zip file. And similar thing you can see for customer profile, or you can also see it for your ingest sensor data. So you can see here that I have configured these 4 jobs to run in parallel, and for each of these jobs I am passing the source table name, destination location, and transformation code location, so that when the job runs and when trying to ingest the data, they can run table specific transformation. So this looks all good. I don't need to save it because I did not make any change. This is how the code look like. What I'm going to do, I'm going to provide this job code, transformation code, and this step function. So job code, transformation code, and this step function, everything I will put into a single zip file, and that I will share as a link in the description below. Okay, so you can download it from there, and if you want to make some changes to it and play with it, you can do that. So now what I want to do is that I want to run this workflow. So if I go to I want to start so this is my JDBC ingestion workflow. Let me start the execution. I don't need to provide any top level workflow level parameters. I simply start the execution. So what now it is going to do, it is going to run these 4 jobs in parallel, and then it is going to ingest my data, and it will also do my data. It's going to do table specific ingestion for me. So let's wait till this pipeline finish the data ingestion for all 4 tables, and then we will go and investigate the data written to see if it has done table specific transformations or not. So let's wait for pipeline to finish. Okay, so you can see here that all my pipeline has finished and all the 4 jobs have finished. So what I can do now, in fact, I can go to my output folder. So if I go to my customer, no, not here, customer profiles folder, and if I try to refresh, now I can see a table, my data there. And if I look at my transformation code, by the way, for customer profile, let me see where is the customer profile. Yeah, here we go. So it's supposed to have a service ID, service used, and age. So let me go back to table here and try to do a select query on this. Query select. This is Apache Parquet. Let's get output in CSV, comma separated, run the query. You can see here there are three columns here. Yeah. Similarly, let's choose another one. Okay, let's go to orders here. Let's refresh it. And for orders, our code was select only order number and amount, nothing more than that. And you can see here, if I simply select one of the files over here and simply say, okay, I want to do this query. Let's close it again. Apache Parquet, CSV, comma separated, show me the result. And you can see here my order ID and order amount. So you can see here each of these actually folders are populated now with my table specific transform data. You can also go to Glue, and if you go to say jobs legacy, and if I select JDBC data ingestion, you can also see some 4 instances of this job had run over here. There's no timestamp, so probably you can't check that, but yeah, it has run. So you can see how you can create a single pipeline with single job, but apply multiple transformation across multiple tables. That can really save you a lot in terms of development, and also enhance your flexibility and reusability. So that was all for today's video, guys. Hope you like the video, and if you like the video, please click on the like button. Please subscribe to my channel. I'll always look forward to your feedback, whether it is for new content, or it is for making any correction in my videos, or if you want to discuss anything from the AWS architecture or design point of view. I always look forward to your feedback and your comments for the improvement. So please provide so. I promise to come back again in a week's time with another such video. In the meantime, please stay safe and have a nice day. Bye-bye.